This is Unit 4, Video 4, Electrolytes. Talking about electrolytes, we're talking about things that in water can cause conduction of electricity. Water itself is non-conductive. You probably heard that, but certain chemicals in water will make water conductive. Other chemicals in water will not. So we're going to look at that. There's three different types of electrolytes: strong, weak, and non-electrolytes. A strong electrolyte makes the water strongly conductive. These are going to be our ionic compounds. A weak electrolyte is going to make it weakly conductive. These are going to be things like weak acids, weak bases. And then our non-electrolytes are not going to change the conductivity of water at all. These are typically going to be molecular compounds. Okay? So let's look at what happens with a strong electrolyte. Ionic compounds are going to be strong electrolytes. Strong acids and strong bases are strong electrolytes. So an ionic compound, great example is salt, NaCl. Sodium chloride. Sodium chloride, when it hits water, it fully ionizes. What does that mean? Well, in water, we're going to have sodium ions floating separate from chloride ions. So you'd say, do they ever stick together? Well, they attract each other, but as soon as they stick, water peels them right back apart. If you ever sprinkle salt down into water and then don't stir it up, you can see the dissolving taking place right across the surface of the salt. And that's because it's a strong electrolyte. So in water, a strong electrolyte completely becomes its individual ions. Now what about a weak electrolyte? A weak electrolyte, great example, is acetic acid. Acetic acid is a weak acid, it's vinegar, and so when it hits water, it only makes a small amount of H+. Remember, our definition of acid at this point is anything that produces H+ or hydrogen ion in water. So a weak acid is going to make HC2H3 too, just not very much of it. So if we just represent a lot of different HC2, H3O2, most of the time the H is bound into the acid, but there will be some small amount of the actual ions produced in the water. Very small amount, reaches what we call equilibrium. A non-electrolyte is something we're going to dissolve in water, still dissolves in water, but it does not cause electrical conductivity. The classic example of that would be glucose, C6H12O6. We dissolve glucose in water, it does not ionize at all. It stays as glucose. We all know it dissolves really good in water, but there's no ionization occurs. If there's no ionization, there's no electrical conduction. If we took some type of electrodes and put those electrodes in here and connected them to a light, okay, so here's my light bulb, we will get a very strong light coming as a result of a strong conductor. So any strong conductor will make this very, very bright. A weak conductor, very faint. A non-conductor, no impact at all.